Hello Year 9, this PowerPoint is to give you a general feedback on the ray diagrams worksheet. I have split it into 3 slides. Each slide is based on the questions in the worksheet. So after each bulleted point, if you click on the play sign, you should be able to hear the feedback about that particular section of the ray diagram worksheet. The first page of the worksheet asks you to draw the ray diagram for 5 different positions of the object. Question 1, 2 and 3 on that page was mostly well answered. You did manage to follow the rules and do the drawings correctly. Question 4, if you're following the rules, you will be able to see that you get 2 parallel lines on the right side of the ray diagram. So when you have 2 parallel lines, they are never going to meet. I repeat, they are never going to meet. So you will not have an image in that case. So if the object is placed at F, you will never see the image. So your answer for that should be no image. Question 5 is a difficult question. So I'm not surprised that only a small percentage got it correct. That's absolutely fine. I'm going to tell you how you can work it out. So again, if you follow the rules, what you would see is you will get 2 lines on the right side of the lens. But when you look at the lens, you will be able to see that those 2 lines are diverging from each other, or you can see that the distance between those two lines keep increasing. So what you generally need to do there is, so if just take them back, look backwards along the direction of those lines, you will be able to see that if you extend those lines backwards, they are going to meet at some point. Okay, so on your ray diagram sheets, what you need to do is those 2 lines that you have drawn there, extend those lines backwards using dotted lines, and you will see that those dotted lines are going to meet at some point, and that is where you get the image. Another thing I saw was the first page of the ray diagrams worksheet. It asks you for 2 things. Draw the ray diagram to work out the nature of the image. So you have to actually work out the nature of the image also, which means you need to tell for in each of those 5 cases, how does the image look like? What are the characteristics of the image? So the image that you draw, if it is smaller in size than the size of the object, you should say that it is diminished. If it is bigger in size, you will say it is magnified. And if it is the same size, that's it. You say same size. Okay. Then another aspect of the nature is, did you get real images or did you get virtual images? If the lines actually met when you drew them, then they are real images. But like in question 5, if you had to extend it backwards, then you call that a virtual image. And then last thing is the orientation of the image. So you can either get it upside down, in that case you call it inverted, or you can get it along the same orientation, in that case you call it upright. Okay, so these are the 3 sections in the case of nature of the image: diminished, magnified or same size, real or virtual, upright or inverted. One thing about the ray diagrams is it definitely needs to have arrows on them. A ray diagram is not complete without arrows on it. I did come across quite a lot of worksheets where the ray diagrams, the arrows were missing. It is not acceptable. So please make sure that whenever you're drawing the ray diagrams, you have the arrows on them showing where it is coming from. The ray diagram for concave lens was mostly well done. The only thing I saw in some of the answers was that you have correctly extended the ray parallel to the principal axis backwards so that it crosses the other line, that is other ray that is going through the center of the lens. But some of you have just left it there like that. Then it's not complete. So where the two rays meet, you need to remember to show the image there. From the image you have drawn, we need to see the size of the image, whether it is diminished or magnified. We need to see whether they are real or virtual. We need to see whether it is upright or inverted. So only if you draw the image there, we can see the nature of the image. Majority of you have drawn the ray diagrams correctly on page 1, but on page 2, when it came to the question, what are the rules for drawing a ray diagram, I got a variety of answers. Yeah, there were answers like the lines should be straight, you need to use arrows. Then there were responses like always use a ruler, make sure the lines always meet. No, those are not the rules. The rules are the ones that you used for drawing those ray diagrams. So what were the rules that you used? One of the rules are a line parallel to the principal axis after refraction passes through the focus. And then the second rule that you have used to draw the ray diagrams, any ray passing through the center of the lens passes undeviated. It passes straight through. So those 2 points are your rules that you are using. After that came the question on the focal point and the explanation for your choice of focal point. Again, a very decent percentage got that correctly. So the answer is A for that, and the explanation, some of you would have to work a bit on the keywords you have used there, because A is the answer because the rays appear to diverge from that point. Okay, since it is a concave lens, the 2 rays drawn on the diagram will appear to diverge from that point. So you have to just polish your answers, most of you, or I would say a good percentage of the students have the idea why it is A. And always keep in mind, in the case of a concave lens, the focal point will be always on the same side as the incident rays. So if the incident rays are coming from the left, the focal point will be on the left. If the incident rays are coming from the right, the focal point will be on the right. Now we have come to the last question on the worksheet, which is explain the difference between a real image and a virtual image. It was well answered by most of the students, and the most popular answer I got was real images can be seen on a screen, virtual images cannot be seen on a screen, which is absolutely fine. There's nothing wrong with that answer. But then I thought I'll just give you a few more things to add to your knowledge bank. In the case of a real image, if you go back and look at question 1 to 5, you will always be able to see that if it is a real image, the object and the image will be on the opposite sides of the lens. So if you have the object on the left, the image will be on the right. If you have the object on the right, the image will be on the left. They will never be on the same side. But in the case of virtual image, it's exactly the opposite. If you have the image on the left, the object will be on the left. If you have the object on the right, the image will be on the right. They will be on the same side. So I just thought you can add that to your notes, or just keep that in mind about that extra information about real and virtual images. So this was a general feedback on the ray diagrams worksheet. I hope you find it useful.